Welcome all for the today's presentation. So today we continue with the biostatistics module, and today's topic for the discussion is hypothesis testing and statistical test. Okay, this topic is also going to be very important from the examination point of view. Few concepts are asked in the part 1 examination, more detailed concepts are asked in the part 2 examination. Okay, so hypothesis testing and statistical test. So why do we need hypothesis testing? Okay, so when actually we conduct the research, basically the purpose of research is to find out some difference, okay, something which is useful, okay, from the traditional, is there something new? So research findings may occur because there is a true difference which is existing, or difference may be occurred by the chance, because we are carrying out here the study or the experiment. This difference which you have noted may be a true difference which is there, okay, in the treatment group and in the control group, or but there is a possibility that the difference is actually by chance, or there may be true difference. Okay, these are the two possibilities which are there. So hypothesis testing helps to determine whether an observed result is likely to be due to the chance. Okay, so we want actually the difference is the true difference and not by the chance. Okay, so uh, what exactly the hypothesis is? The hypothesis is a tentative explanation or assumption about the expected outcome of a study. Okay, normally what we have when we carry out the research, we have a research question. So research question, what we do, we convert it into hypothesis. Okay, so question is converted into hypothesis, and then it is tested statistically. Then we have got two options for creating the hypothesis. Okay, which are those options? One is to formulate null hypothesis, and another is to formulate alternate hypothesis. Okay, so hypothesis is a tentative explanation or assumption about the expected outcome of the study. Okay, so we in priori or in beforehand we comment something about the outcome. Okay, so that is what is your hypothesis. So null hypothesis, that is there is no difference or no association between the two. Okay, so for example, your research question is about new drug is better than the old drug. If this is your research question, what will be your null hypothesis? No difference is found between the new drug and the old drug. No, there is no difference between the, this is what you are assuming. Okay, then if your research question is that zinc levels are differ in the LBW babies, okay, you will put the null hypothesis as there is no difference in the zinc level between the two groups. Okay, then if your research question is smoking cessation programs differ, you will put the null hypothesis, there is no difference between the programs. Okay, that will be the null hypothesis. So null hypothesis is always a no difference, it begins with no difference. Okay, so null hypothesis always state no difference or no association, while alternate hypothesis is something actually in which you are interested. So alternative hypothesis represents what the researcher wants to prove. Okay, say for example, research question is about the new drug, so new drug is better, so you will say in the alternate hypothesis there is a difference between the new drug and the old drug, so difference exists. Okay, then smoking programs differ, this is the research question, you will say difference exists between the two programs. Education is related to the poverty, the association exists, that you will put it into your alternative hypothesis. If this would have been the null hypothesis, you will have be mentioning there is no association between the education and the poverty. Okay, so basically we need to have both hypotheses ready, but when we begin with the null hypothesis, then we carry out the study, then we do the statistical calculation, then we get the result the in form of p value, and then we decide whether to accept the null hypothesis or reject the null hypothesis. Once we reject the null hypothesis, we accept the alternate hypothesis. That is what we do actually. So now here also, if you see new drug is better, okay, now here new drug is better, it can be said in two ways, that there is a difference between the new drug and the existing drug, or new drug is superior to the older drug. Now these are the two different things. When we say that there is a difference can be in either way. Okay, that means it may be more useful or it may not be useful. Okay, but there is a difference. Okay, this is one thing. But when we just say the difference, that means it can be on either side. But when we say it is superior, then we are saying only on one side. We are not talking about the other side. So when we have the test can be one-tailed or the two-tailed test. So this depends upon what you are mentioning in the hypothesis. If we are mentioning just the difference exists, that means we are talking about the two-tailed test. We are not specifying on which side you want to go. Okay, so difference exists, that means it is a two-tailed test. If we say drug A is superior to drug B, that means we are talking only on superior side. Okay, only on one side, then it becomes the one-tailed test. Okay, so two-tailed test states only the difference exists. There is no direction which is specified. Drug A and drug B are different. This is what is the meaning of two-tailed test. Okay, if it is a one-tailed test, that means their direction is specified. Drug A is better than drug B, or drug B is better than drug A. That means you are specifying the direction. Okay, so when your statement says difference exists, that means we are talking about two-tailed test. Okay, when in the sentence you get it is one is higher than other, that means we are talking about one-tailed. If the sentence mentions lower than the other, that means we are talking about one-tailed. If the sentence mentions better than something, then again we are talking about one-tailed. Okay, so this is what you are supposed to know, and that is how you have to select the test also, one-tailed or two-tailed. Okay, so what is the logic of hypothesis testing? Okay, we have just seen that the research question is converted into a hypothesis. Then hypothesis, there are two types of hypothesis: null hypothesis and alternate hypothesis. But what is this logic of hypothesis? So this is explained by the Karl Popper principle, who he has given the principle. It is a proving by falsification. Okay, so instead of directly going to the alternate hypothesis, because we are actually interested into the alternate hypothesis. Okay, but instead of proving the alternate hypothesis directly, what we do, we assume that null hypothesis is true. Okay, that is no difference between the two groups, no difference between the two drugs. We assume that the null hypothesis, then we collect the data, then we look for the evidence against null hypothesis. Then if we found the appropriate evidence, then we reject the null hypothesis if the evidence is strong. So this is the proving by falsification, and this is the stronger way of saying that alternate hypothesis is acceptable. Okay, so this is something like a courtroom analogy. Okay, accused is innocent unless proved otherwise. Okay, so accused is innocent unless proved otherwise. So you have the accused or the defendant, that is same as your null hypothesis. Null hypothesis mentioned that there is no difference. So initially we assume that the accused is innocent, then we collect the evidence. If the evidence is sufficiently strong, an innocent assumption is rejected on this sufficient evidence, then you accept him as a guilty. Same thing what we have mentioned before. Always assume that null hypothesis is true, then collect the evidence. If evidence is highly unlikely under the null hypothesis, you will reject the null hypothesis and you will accept the alternate hypothesis. Okay, so what is the decision process? So decision process, first you talk about the steps in the hypothesis testing. Okay, so what are the tests in the hypothesis testing? First, formulate the hypothesis. Then we will choose the significance level. Okay, significance level alpha, beta, that we are going to select. Then we will select the test. Okay, then we have to collect the data and analyze the data, then compute the test statistic, and we will make the decision. Okay, so same things is explained here. Initially we started with a research question. From the research question we have developed the hypothesis. Then there will be two hypotheses. One is a null hypothesis and another is an alternate hypothesis. What does the alternative hypothesis say? Will say the factor causes the effect. Okay, that is the problem of induction. What does the null hypothesis say? The factor has got no effect. Drug has got no effect. This is the falsification. Okay, so what we accept, we begin with the null hypothesis. We collect the data, we carry out the research, and then we go for the test statistic and we calculate the p-value. We started with the null hypothesis. Okay, so we have accepted this the falsification statement in form of null hypothesis. Then we have got a p-value. Now if the p-value is less than 0.05, that means we have got a strong evidence to reject the null hypothesis, because p-value has come less than 0.5. Okay, so we reject the null hypothesis and we accept the alternative hypothesis because of the sufficient evidence. Okay, if the p-value is more than 0.05, then we fail to reject. We cannot reject the null hypothesis. So that means the alternative hypothesis is not supported. Okay, so we accept the null hypothesis. Okay, so this is the same thing which is explained here also. You have the null hypothesis and you have the alternate hypothesis. Okay, suppose a particular drug which you are under the study, that is giving the good effect. Okay, suppose you are dealing with antihypertensive, the blood pressure reduction is more than 10% with a particular antihypertensive. What you will put as a null hypothesis, the blood pressure reduction is less than 10 millimeters of mercury. You are very interested in blood pressure reduction of more than 10%. You will say the blood pressure reduction by this particular drug is less than 10 millimeters of mercury. So here, this is your null hypothesis. That is the this value which is you are going to obtain is less than the value you are going to consider. Okay, so the blood pressure reduction is less than the 10 millimeters of mercury. This is you are going to be null hypothesis, because you were interested in the more than 10 millimeters of. But if the same study, if you are going to talk about in the alternate hypothesis, you will say that blood pressure reduction is more than 10 millimeters of mercury. Okay, so this is going to be the alternate hypothesis. Same thing. Suppose here on this side you are going to talk about the you are going to talk about, say, intervention and the prevalence of this particular intervention is reducing the incidence of particular thing or the prevalence of particular thing. So you are going to here, if you are putting the null hypothesis, what you will say, the prevalence is more than this particular thing. Whatever is a standard, you will say it is more than. So actually you are interested, the prevalence is getting reduced with the particular intervention, but you are putting the null hypothesis that prevalence is more than the standard what is under your consideration. But you will put alternate hypothesis as prevalence is less than particular thing. Okay, whatever is your standard. So that is, and if you just want to say to tell, there is a difference which is existing. So in the null hypothesis, you will mention that there is no difference. The prevalence remains same here also and in there also. But in the alternate hypothesis, you will mention that there is difference in the prevalence or the difference in the treatment outcome. Okay, so this is what is the null hypothesis and the alternate hypothesis, depending upon what is your outcome interest that you will mention. Okay, now what kind of test you are going to apply? So this is what we have seen up till now is the decision process. Now we will see about the decision tree. Okay, now hypothesis you have formulated, you have decided about the alpha beta levels. Okay, and that is the we have talked about, we will talk about the, so what kind of statistical test will depend upon the relationship between the variable. Okay, now we have got a variables in the study. What exactly you want to do with the variables, whether you want to know the association or whether you want to compare the groups. Okay, so you have got some outcome variable. Now what exactly you want to do with the variable? So if you want to know the relationship between the variable or association between the variable, first thing what you should know is what is the type of variable you have. Suppose you have got a categorical variable. Now categorical variable, always remember NO. The scale is either nominal or ordinal. Okay, categorical variable, nominal or ordinal. Okay, so if both variables are categorical, like the smoking, present or absent, and lung cancer, present or absent, yes or no. So this is a categorical type of data which you are having, and both variable are categorical in nature. Then what type of test you are going to use? The chi-square test. Okay, so for association between the categorical variable, test which is used is a chi-square test. So this type of questions are asked. So it will depend upon the what type of variable you have. We are dealing with the categorical type of variable, either nominal or ordinal, and then in that particular case the test which is preferred is a chi-square test. Okay, here for association between the categorical variable you will use the chi-square test. Okay, now your variables are continuous variables. The scale is an interval scale or the ratio scale, but your variables are continuous variables. Then both variables are continuous, such as height, weight, age, and blood pressure. Then what you are going to do, how you are going to find out the association? By using correlation. It may be Pearson's correlation or it may be Spearman's correlation. Now, what is Pearson and what is Spearman? That yesterday we have seen in detail. So please listen to yesterday's video once again. So correlation, either we are going to use Pearson's correlation or Spearman's correlation. Okay, so for relationship between the continuous variable, we have got a Pearson's correlation or Spearman's correlation. Okay, Spearman when we use, when we have got a ranking of the data. Okay, so if we have got a continuous data, we use the Pearson's correlation. Okay, so this is what about the relationship between the two variables. Now, if we have got a uh, if we want to compare the groups, okay, now comparison of the group, if you have got a mean for the comparison between the different groups, then how we are going to deal with? Suppose we have got a only one sample and we are going to compare the mean of that sample with the population mean. Okay, that is one possibility. Or there may be other possibilities. We have got a two different group. We have got a mean of one group. We have got the mean of the other group, and we are going to compare the both groups with each other. So there are two possibilities. There is a one group for which we have got a mean, and that sample mean we are going to compare with the population mean. This is one possibility. The other possibility is that we have got a two groups and we have got a two means, and we are going to compare the two means with each other, or there may be more than two groups also. Okay, so these are the possibilities we have. So when we are comparing the means, that means we are comparing the group. So we should know what is being compared. If we are going to compare sample mean to population mean, then do we have the population standard deviation? Okay, so population standard deviation, if we have, we will use Z test. That is the one sample Z test. Okay, but if we do not have the standard deviation of the population, then we will use one sample t test. Okay, so when we are comparing the sample mean with the population mean, and we have got a population standard deviation of the population, in that particular case Z test will be used. If we don't have the standard deviation of the population, we will use one sample t test. Okay, so here the chi-square test, here it was correlation, then here it is a Z test or one sample t test, depending upon the availability of the standard deviation. Okay, now if instead of one group we have more than one group and we want to compare the mean, then sample mean to another sample mean we are comparing. Then how many samples you have and whether these samples are paired or unpaired. Now, what do you mean by paired sample and what do you mean by unpaired sample? Okay, now if we have got a two independent groups, suppose one group of 50 women and another group of another 50 women, not the same group, another 50 women we have. Or if we are have a 50 women in one group, 50 men in other group, and treatment is given to both groups, we are comparing such kind of thing, then we are it means that we are dealing with independent groups. But if we have got a same group and we are taking the observation before and after, okay, we are taking some observation, then we are giving the intervention, and then we are taking the same observation on the same group. after the intervention. That means it is a paired observation, not the independent group. It is only one group, but observations are two. Then the possibility with the previous one was there are two observations from two different groups. Here from one group we are getting two different observations. Okay, then the test will be different in both the cases. Okay, so when you have only one group but two observation, that means it is a paired observation. It is a paired observation on the one group only. Okay, before after. Okay, there is a pairing. Okay, so here we are going to use the paired t-test and all. So that we should know when we are comparing the sample mean to another sample mean, are the sample independent or pair, that you should know. Okay, now if we have got an independent, that means two groups are totally different. Then how many groups we are dealing with? If we are dealing with two groups, then we will use independent t-test. Okay, or unpaired t-test also called as. Okay, independent t-test or unpaired t-test, because these are not the paired observations. Okay, if we are dealing with more than two groups, we use ANOVA. Okay, it is a one-way ANOVA we are using. Okay, if we are dealing with more than two groups, remember, when you are comparing more than two groups, the test which is used is ANOVA. This is also one of the frequently asked SBA. Okay, this is also one of the frequently asked SBA. So if the two groups are independent, we will use unpaired or independent t-test. If we are dealing with more than two groups and comparing the observation, then we are going to use one-way ANOVA. Okay, now we have got a paired observation. That means before after treatment, they are related or they are matched. Then how many groups you have? You are dealing with two groups or more than two groups. If you are dealing with two groups, then we will use paired t-test. And if you are dealing with more than two groups, then repeated measures ANOVA. Here it is a one-way ANOVA. Here it is a repeated measures ANOVA. Okay. Now, while applying all this, it is assumed that your sample distribution is normal. The sample is normally distributed and you are applying this parametric test. Okay, but if your sample is not normally distributed, then you cannot apply this particular test. Suppose your sample is not distributed normally and you are in the same situation that it is an independent groups, you are dealing with two groups, then instead of unpaired t-test, you will use Mann-Whitney U test. Okay, here non-parametric counterpart of the parametric unpaired t-test is the Mann-Whitney U test. Okay, here you remember Mann-Whitney U test is the non-parametric counterpart of unpaired t-test. Now here parametric is one-way ANOVA. Here the non-parametric counterpart is a Kruskal-Wallis test. It is a Kruskal-Wallis test. Okay. Now here you have got a two samples which are paired and it is a parametric. It is a normally distributed. So we are using this parametric test. If it is a non-parametric, then you will use Wilcoxon sign rank test. Okay. So here it is a Wilcoxon sign rank test. So these are a couple of tests which you are supposed to know. Okay. The same thing is explained here. What exactly you are going to do if you have got two samples and independent, then it is a one-way ANOVA. You are comparing more than two, related means then repeated measures ANOVA. Okay, like that. Okay. So the same thing is explained here. So what is up till now we have learned? We have first thing what we have done, we have formulated the hypothesis. We have assumed the null hypothesis is true. Then we collected the data. Then we calculated the test statistic. Then we calculated the p-value. Then this p-value is compared with the alpha which is set by us. The alpha which we have set is a 0.05. Okay, so 5% error, up to 5% error we have accepted. Okay, but the p-value has come less than alpha. Okay, so when the p-value is less than alpha, then we will reject the null hypothesis. If the p-value is more than the alpha, then we will not reject the null hypothesis. Okay, now the decision tree what we have seen here, the same thing we are going to explain here. Okay, so when we are talking about the decision tree, what you are supposed to know, what is my objective, what type of data do I have, and how many groups I am comparing. Okay, so what is my objective? So, okay, so this is the what is my objective. here whether to find out the relationship or whether we are comparing the means. That is what is mean by the what is my objective. That is the first thing. Okay, so first thing is the statistical test about the relationship, and second is a comparing. What exactly you want to do, whether you want to find out the relationship between the variable or whether you want to compare the groups. So are we looking for an association like age and blood pressure, height and weight, BMI and blood glucose? Then we are studying the relationship. Okay, or we are comparing the groups. In that particular case, mean HB in the treatment group versus control. You have two different groups and you are comparing the mean HB. Then you are comparing the mean birth weight in smokers and non-smokers. Okay. Then we are comparing the means. Okay. So that is what we have seen in the image there. Okay. So relationship between the variables. What type of variables we have? Suppose if we have the categorical variable that we have seen in the first right sided, that smoking is present, cancer is present. Okay, whether present or absent. So is smoking associated with the lung cancer? Answer will be either yes or no. So what we have got a categorical variable. So the test which is used is a chi-square test. Okay, so this we have seen in the image. Okay, now if we are dealing with a continuous variable, now continuous variables such as height and weight, age and blood pressure, and we want to know the relationship. What we are going to do, we will use the correlation. Okay, so if both are numbers and it is a continuous data, we are going to use the correlation. Okay, now are we comparing one mean or two means? Now the right hand side. Okay, when we are comparing the mean. Okay, right hand side of the image. So when we are comparing the mean, whether we have got a one mean or whether we have got a two means. Now when we have one mean, we will compare the one mean with the population. Now when we are comparing with the population, there are two possibilities. We know the standard deviation of the population or we do not know the standard deviation of the population. Accordingly, the test will be selected. Okay, so here when we are dealing with one mean, it is a one sample t-test. Okay, is my sample mean different from a known population mean? So population HB is 12 gram, your sample mean is a 11 gram. So is 11 gram significantly different from the 12 gram which is a population mean? So here what test you are going to use is a one sample t-test. Okay, now if we have got a two means, then we will ask, are the groups independent or pair? Now, what is independent and what is paired? That also I have explained. Now, if the independent samples are there or independent groups are there, we will go for independent t-test. Groups contain different people, drug A versus drug B, different women in each group. We will use independent sample t-test, also called as unpaired t-test, for the parametric or the normally distributed population. If it is a not normally distributed, we will go for non-parametric, which is a Mann-Whitney U test. Okay, so unpaired test. Okay, unpaired t-test, U for U. Okay, parametric is unpaired t-test. Non-parametric is a Mann-Whitney U test. Okay, remember, if it is a non-parametric, it is Mann-Whitney U test, U for U. Okay, so whenever you see cases versus controls, treatment versus possible, main placebo, main versus women, that means we are dealing with two different groups, then we will always go for independent t-test. These type of questions are asked, they will give you some scenario, then you have to find out what exactly you are comparing the means, then whether it is a paired sample, whether it is an unpaired sample, and then accordingly you will choose the test. Okay, so here when there are two separate groups, you will choose the independent t-test. Now when your observations are paired observations, you will have to go for paired t-test when it is a parametric test for a normal distribution. So same subjects is measured twice, before treatment and after treatment, pre-operative HB and post-operative HB on the same patient. So same women is measured twice. So it is a paired t-test, which is a parametric test for normally distributed data. If it is a not normally distributed, then we will go for non-parametric test, which is going to be Wilcoxon sign rank test. Okay. Then from remembering point of view, we will how to differentiate between the paired and unpaired. We will ask, am I seeing the same patient twice? If you are seeing the same patient twice, that means it is a paired t-test. If they are separate, that means it is an independent t-test. Okay, so the same table which is given in the figure in a small letter I have copied here. So association between the two categorical variables, the variables are categorical plus categorical, so we'll go for chi-square test. Okay, association between two continuous variable and you want to know the relation, you will go for correlation, which may be either Pearson's correlation or Spearman's correlation. Okay, then sample mean versus non-population mean, it is a continuous variable, one sample t-test. Okay, mean of two independent groups, continuous variables, then go for independent t-test. Okay, then mean before and after the treatment, that means it is a paired sample, continuous variable, go for paired t-test. I hope you have got understood this, and I have tried to simplify as much as possible. Okay, these type of tests are asked which test is will be used in this scenario. Okay, so same thing for the if you get a SBA, please understand what exactly you want to know, whether you want to know the relationship or whether you want to compare. If relationship, if it is a categorical data, chi-square test. If it is a continuous data, it is a correlation, that is about the relationship. If it is a comparison, then whether it is a one mean or two mean. If it is a one mean, one sample t-test. If it is two mean, these are the different people, independent t-test. If they are the same people, it is a paired t-test. Okay, so up till now, clear to both of you, doctor?
Yes, sir.
Yes, sir.
Okay. Now, next is errors in the hypothesis. Okay. Up till now, we have seen the how the tests are done and all. Now, errors in the hypothesis. Okay. So what happens? Up till now, we have applied the test, and then depending upon the p-value, we will decide whether to reject the null hypothesis and whether to accept the null hypothesis. So this is another domain which is frequently tested in the examination. It is the errors in the hypothesis testing. Okay, so most frequently tested in the examination is this particular topic. Now, suppose null hypothesis is true. Okay, null hypothesis is true. Null hypothesis is a no difference hypothesis, and it is a true hypothesis. Then you do not reject the hypothesis. That means you are correct. Okay, the null hypothesis is true. You have not rejected the null hypothesis. That means you are correct. Okay, now if the null hypothesis is false, okay, then and we have rejected the null hypothesis, that means we have taken the correct decision. Okay, is this understood? Have you understood this? Null hypothesis is true, and our action is
Yes,
that
sir.
we have not rejected the null hypothesis. That means our decision is correct. Okay, now null hypothesis is false. In reality, we are talking about in reality, not in the study. Okay, so this is in reality. In reality, null hypothesis is false, and we also reject the null hypothesis. That means our decision is correct. That means we have done the right job. Okay, so this you have understood. Do you agree
Yes,
with
sir.
this? Okay, but
Yes,
Yes,
sir.
sir.
now next comes the error. Okay, now in reality, the null hypothesis is true. That means there is no difference, but you reject the hypothesis, null hypothesis. We are committing the type 1 error. In reality, null hypothesis is true. Null hypothesis is the hypothesis of no difference. Okay, that means there is no difference. Okay, and you have rejected the null hypothesis. That means you have imagined the difference. You have imagined the difference. Okay, there is no difference, but you have imagined the difference and you have rejected the null hypothesis. That means you have committed type 1 type of error. Okay, there is no difference. Null hypothesis is true. You have rejected the null hypothesis. You have imagined that there is a difference when there was no difference. Okay, when in reality null hypothesis was true, you have committed type 1 errors. Okay, so here imagine, you are imagining the difference when there was no difference. Okay, no difference means null hypothesis was true in reality. Okay, so that type of error is called as type 1 error when you have imagined the difference when there was no difference. In reality, there was no difference, but you have imagined the difference. So remember, I for I. One first I, type 1, and imagination of difference. Okay. Now, next scenario, null hypothesis is false. Null hypothesis was no difference. It was false. That means there is a difference. Okay. And you do not reject the difference, this null hypothesis. Okay. Here you are ignoring the difference. Null hypothesis is false. That means there is a difference. Okay. In reality, there is a difference, but you are ignoring the difference. That means you are committing the type 2 type of error. Okay. So more frequently they are asking type 1 or type 2. Most of the time it is type 2 they have asked, but type 1 is also asked. So don't blindly select the type 1 or type 2. Understand what exactly it is. Okay. What is type 1 and what is type 2? So what is type 1 error? Type 1 error is also called as alpha error. That means rejecting a true null hypothesis. Okay. That means you are rejecting a true null hypothesis. You are committing type 1 error. That means you are imagining the difference when there is no difference. Okay. So rejecting a true null hypothesis is also called as alpha error, also called as type 1 error. So it is a false positive. Okay. So study says difference exists. Actually, in reality, no difference. No difference is a your null hypothesis. That is true. Okay. So that is alpha error or type 1 type of error. So type 1 is I imagine a difference. It is a false positive. Okay. Then type 2 error is also called as beta error. Okay. Failing to reject a false null hypothesis is your beta error. Okay. Failing to reject a false null hypothesis is your beta error. Okay. I ignored the difference. Okay. There is a difference, but I have ignored. Okay. So in reality, there is a difference. Difference exists. Okay. But study says no difference. That means you have committed type 2 type of error. Okay. So type 2 error, I ignored the difference. It is a false negative. Okay. So this is actually the error table. I will not go more into the detail and I will not cause more confusion because, you know, these concepts, most of the candidates, almost everyone gets confused with this. What exactly? So when null hypothesis is true, and you have rejected the null hypothesis, you have committed type 1 type of error, that is false positive. The probability of that is alpha. That is your alpha error. Okay. You have always set this alpha error to 0.5. Okay. Now, when null hypothesis is false, you have rejected the null hypothesis, that is your correct decision. Null hypothesis is false and you have rejected, this is a correct decision. That is the true positive. The probability is 1 minus beta. Okay. It is 1 minus beta. Beta what we put is to 20%. Okay. 1 minus beta is 80. Okay. So now null hypothesis is true and you are not rejected. That is also your correct decision. That is true negative. The probability is 1 minus alpha. That is 95% times the possibility that null hypothesis is true. Okay. And your decision is not rejected. Okay. Now null hypothesis is false and you are not rejecting a false null hypothesis. That is a type 2 error. That is false negative. The probability is a beta. Beta is we have set to 20. Okay. So here it is 5%. Here it is 20%. Okay. Okay. So in reality, there is a difference and study says there is a difference. That means we are correct. Okay. In reality, there is a difference, but study says there is no difference. That is a type 2 type of error. Okay. In reality, there is no difference. And the study says there is a difference. This is a type 1 type of error. In reality, there is no difference. And the study says that there is no difference. That is a correct decision. Okay. So this is type 1 error and type 2 error. So now here we will talk about the alpha and beta. So level of significance is alpha. This is generally we set alpha to 5%. That is alpha is set as 0.05, meaning maximum 5% chance of making type 1 error. So when we conduct the study, what is the chance that we will commit this type 1 error is 5%. So this alpha also they can ask you, the what is the alpha value which we set is a 5%. That generally we set this to 5%. Okay. So more stringent study, if uh, you can further reduce from 5%, you can make it 1%, you can make it 0.1% also. Okay. So generally most of the time it is a 0.05 we set alpha, but it can be set as a 0.01 also, it can be set as 0.01 also. But smaller the alpha, harder to declare the significance. The smaller the alpha, the stronger the evidence will be needed for the hypothesis. So alpha is the maximum acceptable probability of committing type 1 error. When alpha is reduced from 0.05 to 0.01, the threshold for statistical significance becomes more stringent. Okay. Therefore, stronger evidence, a smaller p-value is required before rejecting the null hypothesis, making it harder to declare a result which is statistically significant. Okay. So if you can further reduce it, but yours you will require more stringent evidence for the rejection. Say, for example, p-value is what we have said is a 0.05. Okay. So now let us go to the power of study. Power of study is 1 minus beta. Okay. Beta error is set to the 20%. So power is 1 minus beta, that is 80%. Okay. So power is the probability of detecting the true difference. So high power means low type 2, like low chance of the type 2 error. Okay. So they can ask you about the power. Power of the study is denoted by, it is 1 minus beta. This formula also is frequently asked in the SBA. Power of the study is denoted by 1 minus beta. Okay. Beta is generally set to 20%. Okay. Now, what is p-value? It is the probability of obtaining the observed result or more extreme result. Okay, that is the probability of obtaining the observed result. Okay, assuming that null hypothesis is true. So p-value, for once we get the p-value, then we apply the that p-value and compare with the other. Okay, so probability of obtaining the observed or more extreme result, assuming the null hypothesis is true. So probability of observing the data given that null hypothesis is true. So if the p-value is less than 0.05, then we say that it is significant or statistically significant. If p-value is more than 0.05, then we say that statistically it is not significant. Okay, this is what practically we do. So p-value is not the probability that null hypothesis is true. P-value is not the probability study is correct. P-value is not the probability result is valid. P-value mentions about the statistical significance. Okay. So 5 steps for the hypothesis testing. State the null hypothesis and alternate hypothesis. Choose the alpha and beta. Okay. Select the statistical test. Calculate the test statistic and p-value and interpret the result. Okay. Now choosing the correct statistical test. Okay. So it will depend upon, the choice will depend upon the number of groups you are dealing with and type of the outcome variable. This is also revision what we have studied. Okay. If we have got only one group, the outcome variable is continuous, we will use one sample t-test. If we have got two groups and outcome variable is continuous, we will use independent t-test when the groups are independent. If we have got a same group, the observations are paired, the continuous data, then we will use a paired t-test. If we have got a more than two groups and it is a continuous data, we will use ANOVA. Okay. Then if it is a one sample and binary or categorical, we will use one sample z-test. If it is a two groups and it is a binary or categorical, we use two sample z-test. More than two binary, we use chi-square test. Okay. So parametric versus non-parametric test. Okay. So when we use parametric test and when to use non-parametric test. For parametric test, there are certain assumptions. The sample is a random sample. The observations are independent and the sample is normally distributed. When these assumptions are fulfilled, we use parametric test. When these assumptions are not fulfilled, we go for non-parametric test. They do not require normality, use ranks rather than the actual values. Okay. So there is a difference between the parametric and non-parametric test. And this is what I have mentioned to you. You have one sample t-test The counterpart of non-parametric is a Wilcoxon sign rank test. You have unpaired t-test, also called as unpaired t-test. The counterpart of this test, non-parametric, is a Mann-Whitney U test. For ANOVA, you use critical values test. Okay, these two are also asked. Then, if you are got a paired t-test, the non-parametric is a Wilcoxon sign rank test. Okay, for both it is the Wilcoxon sign rank test is used. Okay, so from examination point of view, if you have got a skewed data, avoid using t-test. We will use log transformation or we will use non-parametric test. This is not asked for you people. Then whether it is an independent or paired data. If it is independent data, different individuals in each group, such as men versus women, drug A versus drug B, we use independent t-test. Paired data, same person measured twice, before, after, pre-op, post-op, we use paired t-test. Okay, so clinical versus statistical significance. Sometimes we get the statistical significance when p-value is less than 0.05, but this statistical significance does not mean that there is a clinical significance. Okay, that is totally different clinical concept. This is a statistical significance. Okay, so different clinical significance means difference is meaningful in the practice. Okay, so a result may be statistical, it may be statistically significant. Okay, it may be statistically not significant also, and difference may be clinically not important, but it will be statistically significant. Or difference is clinically important, but statistically not significant. These situations can also happen. Okay, so why sometimes p-value also can mislead us. Suppose if you are dealing with a large sample, then there will be, even that there is a tiny difference that will be picked up and it may show significant. Okay, if you have got a small sample, there will be large difference may not reach the significance. Okay, because your sample size is small, then large difference also may not reach the significance. Okay, so here another concept yesterday we have discussed is a confidence interval. So it is always better to use the confidence interval because they show the direction of the effect, magnitude of the effect, and the precision. So when we are interpreting the confidence interval, we always look for the null value. Okay, so null value is 0 when you are dealing with means. Okay, so significant 95% of confidence interval does not cross 0. For example, if your confidence interval is 3 to 10 or -2 to -6 to -2, so this value is not including the 0. That means it is a statistically significant. Okay, what is not significant? If the confidence interval crosses 0, then it is not significant. So for example, -3 to 10. So this confidence interval includes 0. That is why it is not significant. Okay, so for mean difference or risk difference, null value is 0, while for odds ratio or hazards ratio or relative risk, null value is 1. Okay, so another problem while testing hypothesis is a multiple testing problem. When we are testing many hypotheses, there is a possibility of type 1 error, that is false positive. Okay, so if we are testing 100 variable, even with alpha of 0.05, 5 significant results may occur by chance because you are testing 100 variables. So multiple variable testing is not suggested. Okay, so whatever the important concepts what we have studied, null hypothesis is a no difference hypothesis. Alternate hypothesis, that means difference exists. Type 1 error is false positive. Type 2 error is a false negative. Alpha standardly what we set is a usually 0.05. Beta usually 20% or 0.2. Okay, power is 1 minus beta, that is 80%. P-value is the probability of result assuming null hypothesis is true. Okay, if we have got an independent group, we will go for independent t-test. If we have got a paired data, we will use paired t-test. If we have got more than 2 means, then we will use ANOVA for the comparison. If the data is skewed, then you go for non-parametric test or you can take the log. Okay, If confidence interval crosses 0, then it is not significant, and multiple testing will increase the possibility of the type 1 error. Okay, so that finishes the today's topic of hypothesis testing.
Yes, sir.
Yeah, please.
A researcher rejects null hypothesis when in reality the null hypothesis is true. This is type 2 error, power, type 1 error, bias, or confounding. A researcher rejects null hypothesis. Rejector rejects null hypothesis, but when in the reality it is type 1 error, sir.
Null hypothesis is true, but it is rejected. So it is a type 1 error. So rejecting a true null hypothesis is a type 1 error. Okay, or alpha error, that is a false positive. Next.
A study fails to detect genuine treatment effect. This represents type 1 error. Type 2, a study fails to detect the genuine treatment. Detects genuine. This represents type 1 error, type 2 error, alpha error, random error, confounding. A study fails to detect a genuine treatment effect. This represents type 2 error. Type 2 error.
Study fails to detect genuine treatment effect. Genuine treatment is in reality there is a effect. That means we are ignoring the treatment effect. Okay, ignoring is a type 2. Okay, imagining is type 1. Okay,
1.
Are you getting it? I am just making it simplified. Okay, next.
The power of a study is alpha, beta, 1 minus alpha, 1 minus beta, p value. So 1 minus beta.
Yes, power of the study is 1 minus beta. Okay. Power is probability of detecting the effect, 1 minus beta. Next.
Which statement best defines a p-value? Probability that null hypothesis is true. Probability the study is correct. Probability of observed result assuming null hypothesis is true. Probability result is valid. Probability alternate hypothesis is true. Probability assuming null hypothesis is true.
Probability of result assuming hypothesis is true.
Probability. Sir, option E.
It is option C. P value is the probability of observed result assuming the null hypothesis. Okay. Because we have said the alpha, we have said the beta, everything is set. And then we have calculated the p value. So this p value tells the probability of the observed result assuming the null hypothesis is true. Okay. Next.
A researcher predicts drug A will be superior to drug B. This is two-tailed hypothesis, one-tailed hypothesis, null hypothesis, type 1 error, parametric test. So this is better than it, one-tailed hypothesis.
One-tailed hypothesis. Because direction is specified. Next.
Yes, sir. Which test compares BMI between men and women? BMI between men and women. Okay. Chi-square test, pair t-test, independent t-test, Mann-Whitney only test, Z test. BMI is a continuous chi-square test. No, yes or no. Pair t-test. Pair t-test, B.
Why paired? Paired t-test, you need to have paired observation. Here, men and women, then you have two separate groups. Two independent groups you have. BMI is a continuous variable, so independent t-test. Okay. Okay.
Yes.
Next. Dr. Monica, you want to go ahead with this question?
Yes. Question number 7. The weight is measured before and after the diet program in the same subject. Appropriate test is A. Independent t-test, B. Paired t-test, C. chi-square test, D. ANOVA test, and E. Z test. Sir, answer is B. Paired test.
Correct.
Paired
okay. Now, it is clear when we use independent t-test or unpaired t-test when you have got two separate samples. Okay. Paired t-test when you have one sample but the observation is a pair, that is before after. Okay. Then you use paired paired t-test. Chi-square test you will use when you have got a proportion or you have got a categorical data. ANOVA you will use when you have got more than 2 groups. Okay. Next.
Question number 8. Which factor most directly increases study power? A. Increasing alpha error. B. Smaller sample size. C. Larger the sample size. D. Increasing the beta error. And E. More missing data.
Study power is, which factor will increase the study power?
So smaller sample size?
No, you want to increase the study power, no? With smaller size, study power will decrease. So larger sample size. So larger sample size will reduce the random error and the power. Next.
Yes.
Yes.
95% confidence interval for mean difference is -2 to +8 interpretation. Its significance increases, significant decreases, not significant, statistically significant, type 1 error, type 2 error. So it is not statistically significant because it contains.
Correct. And if it is a proportion, then 1 is the null value, right? Okay.
1 is the null value.
Next.
Which is the non-parametric alternative to independent t-test? A. ANOVA, B. Pair t-test, C. Mann-Whitney U Test, D. Chi-square test, E. Z test. So it's C. Mann-Whitney U Test.
Mann-Whitney U Test. It is always remember independent is unpaired. You go with U. Okay. Mann-Whitney U Test. Next.
Which assumption is required for parametric test? A. Outcome must be binary. B. Distribution should be normal. C. Sample size should be more than 1000. Confidence interval crosses 0 and P value is less than 0.5. Distribution should be normal. B.
Yes. For parametric test, it is very important that you should have a normal distribution. Okay. There are certain assumptions that also we have discussed. When to use parametric test, when to use non-parametric test. So, sample distribution should be normal. Next.
Testing 100 variables in the data set primarily increases risk of A. Type 2 error, B. Loss to follow, C. Multiple testing error, C. Confounding, and E is selection bias. Sir, C. Multiple testing error, type 1 error.
Type 1 error. Multiple testing, type 1 error. Okay. So multiple comparison increase the false positive type 1 findings. Okay. So that finishes today's topic of hypothesis testing. Thank you.